Okay, let's try finishing 13. So we know that the slope is staying the same and that it's just the y-intercept that's changing. So if we look at this, the last line says the resulting line would be parallel to the original line. We know that if they're parallel, that the slopes are the same. So because they're staying the same, then they're going to be parallel. So D is going to be the correct answer to number 13. Okay, 14 says that on a map of downtown, 11th Street is parallel to Avenue M. The equation y equals negative 4x plus 3 represents 11th Street. If Avenue M passes through the point 5, 9, which of the following would represent the equation for Avenue M? So if we're looking for parallel lines again, the slope for this line is going to be negative 4. So that means the slope for my new line also has to be negative 4, and we're passing through this point right here. So again, we are going to put this into point slope form. So let me write that up here. So I'm going to have y minus my y, which is 9, equals my slope of negative 4 times x minus my 5. And then let's simplify that. So we're going to distribute. So I will have y minus 9 equals negative 4x, and a negative times a negative is a positive 20. And then I'm going to add 9 to both sides. And I will have y equals a negative 4x plus 29. So it looks like B is going to be the correct answer. Okay, 16 says a function is described by the equation y equals 2x squared minus 5x minus 3, in which y is dependent on x. If a value for the independent variable is selected from the set, negative 4, negative 1, 0, 2, and 5, which of the following is a corresponding dependent value? Okay, so again, we can put this in our calculators. Let me clear all that other stuff off. Let me get the calculator up, and we're going to type in that equation in the calculator. So let me go to a new document page. And again, I'm going to do a graph. So that's number 2. And we're going to type that equation in. Let me get that up on my sheet. Hang on. Okay, so it's going to be 2x squared. So 2x squared and minus 5x, and then minus 3. All right, and if we hit enter, it's going to graph it. But remember, we're not really concerned about the graph. We want to go to the table. So if I do Control T for table, there I'll have my table. Okay, now based on my question, we had the following numbers. Let me put it up here. We had a negative 4, a negative 1, a 0, a 2, and a 5. Those were my x values, because those were the independent variables, right? And we were trying to find the dependent variable that would match. So if I just arrow up, sorry, let me do this. I arrow up to, negative 4, here we go. Negative 4 is 49. Okay. And negative 1, oh, is right here at positive 4. And 0 is right there at negative 3. Okay, let me keep going. We need 2 and 5. So let me get both of them up here. Here we go. 2 is right here at negative 5. And then 5 is right here at 22. Okay, so now let's go back to our problem. And so it's saying that using one of these numbers, I got one of these answers. So if we look, 49 is not listed. So that one's not it. 4 is not listed. Negative 3 is not listed. Negative 5 right here, and 22 not listed. So this is going to be the answer that they were looking for. So that meant that they plugged in a 2. And they ended up with negative 5. But this was the answer we were looking for. So number 16 says, if the slope of the equation y equals negative 3/5 x plus 4 is changed to positive 3/5, and the y-intercept is changed to a negative 4, which statement best describes the situation? So my new equation would look like this. 3/5 x, and then instead of plus 4, I'd have minus 4. All right, it says the new line is perpendicular. Well, we have 3/5 and negative 3/5. They're opposite but not reciprocal, so that would not be it. The new line is parallel to the original line? No, because they're not the same. The new line and the original line have the same y-intercept. Well, this is a negative 4 and this is a positive 4, so no, that's not going to be it. And then it says the new line and the original line have the same x-intercept. Well, process of elimination, that's going to be it. The bottom line is if we actually graphed both of these equations, which I'll do right now. If I start at negative 4, here we go, negative 4, and I go up 3, and then over 5, 1, 2, 3, 4, 5, and up 3, and over 1, 2, 3, 4, 5. Okay, without a ruler, this is a little hard to do, but here's my, that's the new line, because that's in pink. I'll do the original line in blue. So this was a positive 1, 2, 3, 4, and then we went down 3 and over 5, and then down 1, 2, 3, and over 5. And again, without a ruler, it's hard to show that, but bottom line is they are crossing at the x-intercept. So they're going to have the very same x-intercept, okay? Which of the following graphs best represents the solution to the system of linear equations shown below? Okay, so we're just trying to figure out where they're going to cross each other, right? Which is the solution. So if it's a system, let's use our calculator. We're going to pull up our calculator. Let's go to Scratchpad. So I'm going to go to Home. I'm going to go to Scratchpad. And then we're doing Menu, 3, and then Solve System of Linear Equations. And all that's good, so just hit enter, and then I can start typing. So I have x plus 5y equals negative 5 for the first equation. My second equation is 4x minus 3y equals negative 20. And hit enter. So it crosses at negative 5, 0, or that's my solution, but that means that's where the two lines are crossing each other. So negative 5, 0. So let me pull that up. Okay, so let's look. Negative 5, 0. This is at 5, 0. This is at, I don't even know, negative 4, 4, negative 2. This is at 1, 2, 1, 2. I can't tell. That's not negative 5, 0. This is negative 5, 0. So here is going to be our correct answer. Number 18 is asking which of the following equations best describes the line through the points listed in the table below. So we do a couple different things. We can take this information right here and put it into the calculator and come up with an equation, or we could take a couple of these points and plug in and see which ones actually work. I think I'm going to go to the calculator though. And so we're going to have to go back to a new document. Don't save anything. And I want to do a list in a spreadsheet again. So here's mine. And my x values are going to be 1, negative 2, negative 1, and 0. And my y values are 1, 10, 7, 4. Oh, excuse me, 7, 4. There we go. All right, so then we're going to go to Menu, 4, 1, 3. Again, an x and a y. And then we can hit our enter. So my m is negative 3 and my b is a positive 4. So let's go back to here. Our m is negative 3, and our b was a positive 4. So that meant our equation is a negative 3x plus 4. But look at all your equations. None of them are in slope-intercept form. But it looks like we just have to move this to the other side. So if I add 3x to both sides, that means I'm going to have a positive 3x and a positive y equals a positive 4. Do we have this anywhere? 3x plus y equals 4. Yes, we do right here. Okay, number 19 says, which of the linear functions below are equivalent to y minus 8 equals negative 1/2 x plus 10? Okay, so first of all, I think I'm going to rewrite the original equation and put it into slope-intercept form. So I will distribute this. That means I have y minus 8 equals negative 1/2 x minus 5. Add 8 to both sides. And that will give me negative 1/2 x plus 3. So I'm going to look over here right away and see if I see any of them that are matched. So a negative 1/2 x plus 3, so 2 is going to work. So because this is negative 1/2 x minus 5, obviously these can't be different. So that one's not going to work. Now the other ones, I think at this point it might be easier for me to change each of these into slope-intercept form. So I'm going to, I'll tell you this, I'll do different colors. I'm going to start with the third one. And I want to get the x to the other side. So I have 2y equals a negative x plus 6. Divide everything by 2. And I will end up with a negative 1/2 x plus 3. And that's the same. So that one works. You get a different color. The next one is going to be the x plus 2y equals 3. Again, subtracting my x. I will get 2y equals negative x plus 3. Divide everything by 2. And I will get the negative 1/2 x plus 3/2. Not a 3, so that one doesn't work. And the last one I have is 2x plus 4y equals 12. So subtract 2x on both sides. 4y equals a negative 2x plus 12. Divide everything by 4. And I get the negative 1/2 x plus 3. Again, same thing. So I'm looking for an answer that has 2, 3, and 5 in it. So it looks like D is going to be the correct answer. Okay, on number 20 it says the linear inequality negative 2x plus 3y greater than 12 is graphed below. Which of the sets of points are solutions to the linear inequality? So it's not asking us to graph, it's already graphed for us. They're just asking which one of these sets of points would be in the solution. And we know that the solution area is going to be anything that's in the shaded area, okay? So 0, 0 is right here. So because this is in here, no, that's not it. If I look at B, I also have 0, 0, so that's not going to be here. So let's go to the next one. Let's do a different color. I've got 0, positive 5. That's in the solution. I've got 0, positive 9, that's in the solution, and then I have positive 3, positive 6, which is on the dashed line. If that was a solid line, that would be included, but because it's dashed, it's not. Okay, so let's look at another one. Obviously, I think it's got to have to be this one, but I have negative 5, positive 5, which is right here. A negative 2, positive 5, also right here. And then 0, 9, again right here. So all of these are in the shaded area, so that would be my correct answer.